Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we will take number 31 NEET Physics paper 2015. Students, let us solve the question, that is question number 31. It says that a resistance R draws power P when connected to AC source. The resistance R connected to AC source, it draws a power it draws is P. If an inductor, when an inductance is now placed in series with the resistance, now in the second situation an inductance is placed in series with this resistance such that the impedance of the circuit becomes Z. So the impedance, the total resistance offered by RL circuit to this is Z. The power drawn in this situation, what is the power drawn? That is what is to be found. Power is V square by R. We know that power is V square by R. This is the formula you use. Okay. Here, because it is not a DC source, it is AC source. So in AC source, we have to use RMS, root mean square voltage. So then this becomes power is VRMS square divided by R. This formula we use. And the average power that is consumed in case of this type of circuit, because this is the resistive circuit, and in the resistive circuit the power is VRMS square divided by R. If in case this is a DC source of battery V volt, then it would have been V square by R, but because it is AC source, it is VRMS square by R. So this is the first case in this first situation. This is situation 1. This is the second situation. This equation 1 stands for this situation, and we will write for situation number 2. For the second situation, when inductance is put in series with resistance, then it is a case of RL series circuit. In RL series circuit, we have the impedance is Z. So the power is average power, and that average power, suppose that I call P prime, that average power is VRMS IRMS cos of phi. This is the formula we are going to use for that RL circuit, where cos phi is the power factor. These are the root mean square values of current and voltage. Now IRMS and that in terms of Z I will write, then we know how to write that. So cos phi, I can write for cos phi I will write R over Z, because this is R, this is L. So this is phi, this is Z. Cos phi is this divided by this. So this is the vector diagram. Anyway, this cos phi is R by Z. So I will put VRMS as IRMS into Z. So IRMS is VRMS by Z, so this is VRMS and this becomes VRMS by Z. IRMS is VRMS by Z and this is R over Z. Cos phi is R over Z. Our aim is to write this power drawn P prime in terms of the initial power P. So P prime as a function of P I have to derive. So in this situation, if I know what is P initially we got as VRMS square divided by R. So in place of VRMS square here, I'll put P into R and that I put here VRMS square. So this will give me P prime is VRMS square, which is PR, and this is R divided by Z square, R divided by Z square. So this becomes P R square, R is R square over Z square. So from here I can write P prime as P R over Z the whole square. So this is what you are getting finally, P R over Z whole square, and therefore this one is the correct answer to this question. Okay, thank you.